Doug, KV1MHD. We're wrapping up bench testing here of our KISS TNC. Our KISS TNC consists of an Arduino Pro Mini. That's the blue board there. Controlling a HamShield Mini by Enhanced Radio Solutions. That's the green board. There's some Kapton tape over the board, so when I bind the two together to go into its enclosure, we won't have any shorting. But the core of that HamShield Mini is a AT1846S RF chip, or transceiver chip, and those are used all over on a lot of the Chinese 2-meter and 440 radios, like the Baofangs and the other cheap import radios. So putting this together, there's an example libraries of how to program the Arduino to act as a KISS TNC. We did run into a few issues that we had to work through. The original code had the pulse width modulator amplitude coming out of the Arduino set too high. It was overdriving the mic input on the HamShield. So we saw that on the scope, and we're able to use one of the methods in the library to tune down the output amplitude for your transmit audio. So now we have the expected transmit audio, which I'll show you in a minute. One more quick thing before you can program your Arduino board from the computer or start up your packet program that you want to run. The serial port, you're going to need to add your user that you're logged in as. You need to add that user to the dial-out group. Otherwise, you'd need the root permissions to access the serial port. So this is the command that you'll enter. Once you enter it and enter the root password, you're going to have to log out and then log back in order for those permission changes to take effect. And then you'll be able to run your Arduino IDE to program the Arduino or run whatever packet program you plan to use. Okay, onto some RF verifications now. We have the scope channel 1 hooked up to the speaker output of the HamShield Mini, and we have the HamShield hooked up to my external 2-meter antenna outside. And as I mentioned before, one of the updates that we did to the source code was we turned off the squelch. So the squelch is disabled on the HamShield, and so what you're seeing right now is the noise floor. And what we're going to look for as I'm talking here is as the packets are coming in, you're going to see the 1200 and 2200 hertz tones start to appear and kind of emerge through the noise there. We'll see if we get a strong packet coming in. And we're just looking to verify the quality of that output audio. We don't want to have any distortion, and that'll give us an indication that everything's working properly. So give it a minute. Right there. So you can see the 1200 and 2200 hertz tones coming in, and you can clearly distinguish them from the noise. So this gives us a nice verification that the HamShield is configured, and we're giving a nice clean audio signal into the Arduino's analog to digital converter channel 2. I'm going to do a quick demonstration of the transmit functionality. Actually, transmit and receive gets verified in this test, but we have the handheld, the ASU VX150 handheld, just tuned to the APRS frequency, and then I'm running Yak on my laptop, and you see the receive is working. We got a couple of stations coming in local. I don't have a very we just have an antenna hooked up inside, so I'm not getting as many stations as we had the other day in the shop. But so I'm going to ping N1HRK-15, and you'll hear our generated transmit audio on the handheld. Okay, so you can actually hear our audio being transmitted and the response from N1HRK. And if I go up to messages, so we'll look at the raw messages. You can see here that we pinged N1HRK. I don't see a response there yet. Let's try again. Okay, and we'll pull up the messages. Okay, here we go. So you can see here we sent KB1MHD to N1HRK. We sent a ping message, and we received responses for both of our pings. So this is our round trip communications verification. So the HamShield and Arduino KISS TNC is operational. We're only running 200 milliwatts on the HamShield, so not bad for out of the garage to get a response. So it's a good RF verification. So on to the integration with the drone.